to everything, but yeah. So let's get started. Just quick introduction of myself. Hello everyone, Vijendra here. I run a firm called Alumnix AI Labs. I have my website at alumnix.com. So you can check out some of. So I run this program for upskilling in data science and AI. Okay, so I'll just put it in the messages you guys can explore right when you have time. So there is one program I run, which is the AI and ML upskilling and placement program, right? So I just put the link as well. You can look at it whenever you have time. Okay. This is what I do, and as part of our cohorts, we build a lot of stuff. We have a couple of products. One is Agri GPT for Indian farmers. We build that, and we also have a product called Study Buddy, right, for our EdTech program. So that's how we are effective at helping our folks get better at what they are learning, right? So again, that's an agentic AI application. Both of them are agentic AI applications. One is for Indian farmers, others for the EdTech domain, right? And while we are doing these experiments, whatever we're learning, right? I try to kind of connect these sessions once in a while to share what our experiences are, right? So let's get started. So today's session, I wanted to talk about an attempt we made to build a mini GPT. And what was the reason? The goal is primarily to see if we can build something that is not very complicated and something that can help us along the way. See, today, if you see AI agents, when you build AI agents, you typically make an LLM call, right? And what is the primary reason we make LLM calls? It's like the brain and the body, right? So the brain is kind of understanding the intent and trying to route it to various tools and gets the response from the tools and it returns back, right? So sometimes these intents are very simple, but still we go for LLMs because we need someone to understand the natural language, right? So that's where we thought, why don't we just try building something, see how it works? I mean, let's get it going, right? And the again, just about curiosity, right? Why, if somebody is building, if OpenAI can build, why can't we, right? So the key takeaway for all of you from this session should not be that you become an expert in the entire transformer architecture, but to understand the process of what it takes. What would OpenAI do if they were to build a new GPT from scratch today, right? So it should give that knowledge to you to explore on your own and try it out on your own, right? And who knows, something might come out of it, right? So I will continue this series. So what we learned right now, I'll show you how we built a bare bones model using Wikipedia data, what were the gaps and how bad that model was. And then what we try to do using a narrow domain, right? Narrowed data set, right? So let's get started. So before we get started, I think a lot of you would have joined this for the first time, right? I conducted a session last weekend also, but I'm not sure how many of you were there in that session, so that I just repeat or not repeat some of the stuff, right? So certain things you should have a basic idea of in terms of weights. You should understand the next token prediction and the importance of next token prediction, right? In GPT architecture, right? So what I'll do is I'll still go ahead and skim it a little bit faster than I did last week, okay? So that it still gives you some context, okay? So this is the main thing about GPT. The GPT architecture is, even ChatGPT's models are predicting the next token, right? That's it, right? The central tenet is, if I give a sentence, how do I predict the next token, right? So let's say I say, what is the capital of India, right? So you see the model immediately responds New Delhi, right? So can someone answer like how that New Delhi comes? How does New Delhi come from? Is there a database out there in the ChatGPT's model? But if you ask some other question, like, tell me about Lionel Messi's visit to India, it says searching, right? It says searching, gets data from outside and gets it out. But when you ask what's the capital of India, capital of Russia, it immediately gets the data out, right? How does it get it? Anyone?
With the embeddings, maybe?
Yeah, but where is New Delhi exactly? Is it like stored somewhere in the ChatGPT's model head, somewhere, New Delhi, capital of India? No, it's not from the web, Vivek, okay? So if you want, you can actually search it yourself. You can use ChatGPT yourself, right? You can see here, you can see my screen. What is the capital of India? You see how fast it responds, right? I'm just hitting what's the capital of India. It just says New Delhi. It's not saying searching, correct? So if you say something like, tell me about Messi's visit to Hyderabad in whatever in 2020 recently, right? Let's say, okay. So it's just searching the web. You can see that it's searching the web and getting the data. So yeah, somebody was saying something.
Yeah, so as far as I know, this is because it is trained on a large amount of data. So in some of the data, there might be a data called like the capital of India is New Delhi.
Okay.
So it is trained by token. So it is predicting, okay, capital of India means the next part should be New Delhi.
Correct.
And then it is printing out that answer. And it was trained on a limited set of data for like maybe 2020 or 2021 or whatever it is. So now I think they have integrated a agent or something, so it can generally search the web and get the answer for whatever it doesn't has the information for.
Yeah, correct. That's right. So basically, New Delhi is nothing but the token, right? New and Delhi are two tokens, and it just decodes those tokens into English words, correct? So I'll talk about how it works in subsequent slides, where we look at how we take a corpus of data and we convert it into tokens, and we create embeddings out of it, and then when the token is predicted, how do we get back to the original word? Okay, so that should be the takeaway from today's session. I cannot get into the in-depth of the feed forward and all the architecture of transformers, but the high level is, if you can understand, is good enough. Okay, so typically, if you look at it, I mean, this is how a typical neural network looks. So you have various inputs. The inputs are nothing but the words you're entering. Okay, what is the capital of India? Is each one of them is one input. It gets into the neural network, the various layers, right? These are all the hidden layers, and there's the output layer, which is the output you're getting, which is New Delhi, correct? So under the hood, what happens? Pretty much you have the input layer and the hidden layers and the output layer, and in each of these hidden layers, you are doing, it's kind of computing every node, right? You see every circle here is a neuron, right? And each neuron does computations. What is the computations? The compute is nothing but it computes something called z is equal to w1 x1 plus w2 x2 so plus so on, where w1 w2 are all the weights corresponding to those edges that you see, correct? So if you see the x1 x2 over here, they're all linked to, see, this particular input one is connected to all the neurons in the first layer, correct? So there'll be if there are 10 neurons, there'll be 10 weights, correct? The second input is corresponding to 10. So the total number of combinations are inputs multiplied by total number of neurons, right? So each neuron computes this total and passes through an activation function, which is a nonlinear function, can be ReLU, sigmoid, or tanh, and then it computes an output, and that output goes to the next layer. Okay, so don't worry too much about this. Okay, so the important thing is weights and parameters, right? So most of the times we hear 40 billion parameters. So Llama is 40 billion parameters, Gemma is 3 billion parameters. I don't know, ChatGPT now it has some trillion parameters or something, correct? So what is the difference between parameters, weights, and biases? Can someone tell me? Parameters, weights, and biases. So sometimes people say, it has 40 billion parameters, means it also has 40 billion weights, right? People say that, right? Can you hear that? And you see literature, loosely sprinkled, but technically it's not correct. So weights and parameters are not technically equal, right? There's a slight difference. Does everybody know what's the relationship? Parameters, weights, and biases. Parameters, weights, and biases. That's correct, right? So parameters are weights and biases, and yeah. So how is the relationship working? Okay, so typically weights are what are the knowledge that the model has, right? The ultimate thing is about weights, not about parameters. Parameters, we say, is the sum of weights and biases, correct? So weights, if you see, these are, suppose there are 1, 2, 3, 4, 5, 6, 7 neurons in this layer and 7 neurons in this layer. So you'll see that each one of them is connected by one weight, and the total number of weights that you will get out of this is 7 into 7, that is 49, correct? But bias for each neuron is only one, right? So if you see there are 7 neurons, you'll have 7 biases here and 7 biases here, correct? So typically, if you look at weights and biases from the mathematical standpoint, correct? So let's say, let's just try to put in some numbers here to get some idea, right? So total, let's just close this. So again, why do people use them interchangeably, correct? So let's say there are 7 neurons by 7 neurons, right, into subsequent layers, right? So that's 49 weights, right? Because we said each edge is one weight. So how many biases will be there? 7 plus 7, that's 14, correct? Now let's say you have 100 neurons, right? 100 by 100. So that will be how many weights? 10,000, right? 10,000 weights plus 200 biases, correct? Now let's say I make it 1,000, right? By 1,000. So you start realizing that the total, okay, even if you take this one, 100 by 100, you see that the weights, the biases are very significant insignificant as compared to the weights, correct? So typically, if you look at the entire model, the total parameters is equal to the huge number of weights with a small number of biases. So that's why they say it's negligible, and that's why you use it interchangeably. Okay. So total parameters you say are total weights, but pretty much weights are the knowledge that the model has. Okay. The ultimate knowledge is the weights. So ultimately, you need to adjust the weights, so that the model can get better. So again, I won't spend too much time on this. Okay. So let's look at the simple question in terms of see, again, if you see, each layer has weights and biases. Okay. So all of these together is the model parameters. Okay. Now, let's look at the question of what is the capital of India. Okay. Now, let's answer this question. How are we getting this knowledge? What's the capital of India? So typically, a lot of people think there is a database inside the model. Okay. Just storing all these things. So they think that it's understanding the intent and getting it from the database, but it's not true. It just decodes the tokens corresponding to New Delhi and it gets it out. So it does not look up facts like Google. Okay, it just predicts the next word. The ultimate thing about GPT is predicting the next word. That's it. There's nothing more in that. Correct. So suppose you have a question, what is the capital of India? It breaks it down into tokens. The first thing is it breaks it down into tokens, and each token becomes a vector of numbers using embedding parameters. Okay, so you break it down into a vector of numbers, and then then attention, right? Again, the central tenet of transformer architecture is attention mechanism, right? So in 2017, Google published this attention is all you need, right? I think you folks might be knowing it, but for those who don't know it, if you are in the space, you should know that attention is all you need. This is paper published by Google in 2017, right? So it is the first foundation for the transformer architecture, and before Google can come out, OpenAI came up with their own version of this. Okay, so OpenAI did not come up with an exact replica. They came up with their GPT architecture, which is slightly different from what these guys said, right? So here you have encoder, decoder. There they came up with only decoder and built their own thing. Of course, all credits to them. It's not that they just copied this work, correct? So, but OpenAI first came up with the model. Which year? When did OpenAI come up with it? Anyone? When is the first major public launch of GPT?
2022.
2022, right? Yeah. So once it came out, then it created a flutter, right? Oh my God, what? This is awesome, right? So again, how is this capital of India coming up? So we are saying that it's based on attention, right? It's saying capital India, right? So typically, whenever it says capital and India, it means the next thing is it should see a capital, which is New Delhi, because it is seen millions of sentences like this. The capital of India is New Delhi. India's capital, New Delhi is the capital of India, and all. Right. So it's seen this millions of sentences, and its weights have been adjusted. That whenever it sees capital plus India, the next prediction is New Delhi. Okay. So that's how it checks the probabilities. And it says if New Delhi, then capital of India is high, Mumbai capital of India is low, India capital of India is very low. So these are the probabilities which computes, and it comes up with the next token prediction, correct? Now, again, these next token predictions are all tokens, and tokens are mapped to vocabulary. So I'll talk about it as we go ahead, okay? So this is a very high level about how you come about with next token prediction to arrive at New Delhi, okay? So what we'll do is, next I'll talk about the series of steps we take to build a mini GPT, okay, using Wikipedia data. So we'll close the session at 12, okay? So that way we will keep it focused on whatever we need to cover by then, okay? So if you have any questions, feel free to ask, but pretty much I'm letting you know that I won't drag it too long, okay? So the first thing is, we are teaching a computer to read a lot of text, okay, from a lot of places. learn the patterns around it and guess the next word, right? So this is how ChatGPT works. Just like, what we are trying to do is at a much smaller scale, correct? So whatever your pipeline is, right? It's more like go to Wikipedia, get the data, clean it up, convert it into numbers, train it on those numbers, and then use that trained model for next text generation. Okay. So typically the steps involved are this, right? So download the Wikipedia data, pre-process it, tokenize the corpus, right? And create the sequences, train the GPT-2, and test the generation. Okay. Now what I'll do is I'll actually show the files also to you. Okay. It's not just some theoretical session. I'll show you the files on our GPU server, which is an NVIDIA 810G. Okay, which typically costs around 40,000 or something if we run just like 7 hours a day, right? So so the first step is we download the Wikipedia data. So naturally, ChatGPT also downloads petabytes of data, but we cannot download petabytes of data. So we said, hey, let me just pull in some Wikipedia data from Kaggle. Okay, and we save this data into our system. And we said, okay, this is my raw data. Let me just build my model on top of it. Okay, so what we are building is pure from scratch, guys. We are not taking any existing GPT-2 from somebody and then trying to do some add some dress on top of it and do it. Okay, so it's pure play from the scratch up. Okay, so first is Wikipedia data. So again, let's look at the so this is the GPU server. Okay, what we have, what I'm connected to over here, I already connected to it. So how do we test if it is a GPU server or not? Anyone? Or is there a GPU on this? Again, not people from my cohort race. Okay, so anyone from outside, can someone tell me how do I check if there is a GPU attached to this server? This is an EC2 machine. Okay, clearly from AWS. Anyone? How do I find out if this is a GPU attached and what is the configuration of the GPU on this? Can someone tell me how do you detect if there is a GPU attached? What's the command, right, rather?
It's NVIDIA SMI command.
Yeah, that's right. Yeah, it's NVIDIA -SMI. Okay, so moment you run NVIDIA -SMI, oh, okay. So it's not loading. No driver mismatch. Okay, what happened to this? I think it was working. Let me just check. Let me connect again. Failed to initialize NVML driver. What happened to this? I don't know what's the problem. So
can we check the driver first, like NVCC space -FM version once?
NVCC?
Space -FM version.
It was working since till morning, so I have to install. Okay. Oh, okay, I got it. Today morning I was trying to do Torch. I installed Torch and I think that's messed it up. Yeah. Okay. Don't worry about it. We have an NVIDIA 810G link to this. Yeah, actually, you know what? I was trying to print the file of one of the .pth files, which is the Torch output. So it said that you need to install Torch, and I did that, and I think it messed it up. So typically, you need to. I think if we if you install NVIDIA CUDA toolkit, it will come up. But it's okay. Let's not spend time there. Okay. The important aspect to know it, you just use NVIDIA -SMI, right? You can use the same thing even when you use Google Colab, right? To check what is used there. Okay. So what is the typical GPU on Google Colab? Anyone? What is the typical GPU provided by Google Colab?
Yeah, usual GPU T4.
T4 GPU. That's right. Yeah. So what we are doing is what we use is a much more powerful version of that. Okay. So now coming back, what we did is first step is download Wikipedia data. So I'll just go to that folder where we okay. So I'll walk through the files also, right? I'll just quickly touch on them so that you get some hang and feel of what the stuff is about. So so the first one is download Wikipedia data. Okay, so in this one, I hope you can see my screen, right? So we just went in, downloaded the Wikipedia data from there, dumped it into a .xml.bz, bz2, and then extracted into simplewiki.xml. Okay, so this made sure that we had in terms of the size, right? In terms of the size, where is the slide? So it's important to also get a feel of what is the size of the data that we are operated on, right? So the raw file is this one. So what it got downloaded as, right? So yeah, so it's around 326 MB, correct? What got downloaded, as a zip compressed file. Okay, so then what we did is we extracted it so that we get the data out, and we should be able to tokenize it. Okay, so it got extracted around 1.6 GB. Okay, now this is the raw file we've used to kind of tokenize it, correct? Now, if you wanted to just see like what are the contents, okay, now how does it look like? Okay, so this is how the data looks like, guys. Okay, you pull the data from Wikipedia. This is how the data looks. It's all over the place, right? So it has April, and of course, they're not getting data for you, right? They have the data, you're pulling it. Now it's your job to figure out what you want to do with it. Okay, so the very first data, this is how even ChatGPT gets the data, right? From all the sources it gets data like this. Real, look at all this data. There's nothing very organized about it, correct? But that's how it is. Now you have to figure out how to kind of organize it. Okay, so data is still raw and not in a format that we can process. Okay, so that's the first step. Second thing is we pre-process the data. Okay, so we go to to_process. Okay, so I'll get out of this. Let's look at this file. Okay, so in this process Wikipedia data, what we do is we take that simplewiki.xml. Okay, and we create a corpus file so that it's much better. So we do various regex, right? We say remove this, strip that, strip this, push it out, and then you put it into a format that's more readable for me. Okay, so that's what we're doing in the second step. And basically we are cleaning the Wikipedia text, removing the headings, URLs, extra spaces, weird symbols, okay, and all that stuff. So it becomes much more human readable, right? The intent is not human readable. The intent is more for the system to process it in a much organized manner. So the output is simple wiki, the Wikipedia _corpus.txt. So we'll just look at how it looks. So pretty much this is how it looks. Okay, you stripped it out of all the all the miscellaneous characters and got it into a format that's more like just text, which we can process, right? Now, why do we need this text? We need this text because we want to tokenize it. The next step of the whole process is we need to tokenize it. Okay, now let me so now that we are done with the second step, which is pre-processing, the third step is we need to tokenize it. Okay, so there is a file called tokenizer.py. In this one, if you see nano tokenizer. Okay, so this is the tokenizer which we have written, which is called advanced word tokenizer. Okay, so just like we built our tokenizer, ChatGPT has its own tokenizer. Okay, so what is the purpose of tokenizer? It's to convert all those words which I just showed you now, okay, the big paragraphs of text, into small words and map those words to token IDs, correct? So typically people think every word is one token, right? So can someone answer how ChatGPT answers, charges us, right? When you use ChatGPT for model prediction, right? How does it charge us? On the basis of tokens, correct? So is it just input tokens we give? Is it just on the basis of input tokens we give?
Input and output both.
Input and output, right? Yeah, basically input and output, right? So output tokens as well, right? So because it charges us for input and output tokens, it's important to understand tokens. Important to understand how that ecosystem works. Okay, so if you see here, we are looking at an advanced word tokenizer. It's a very simple tokenizer. If you look at it, there's no jazz. We build the vocab, right, based on this, and we define unknown words, pads, boss, EOS, and all those stuff, right? So again, very simple encoding, decoding, right? So again, even our tokenized algorithm is very simple. We just put a simple regex for this and create the tokens out of this, right? But typically, if you see ChatGPT and all, they don't use such a simple tokenizer. Okay, can someone tell me what tokenizers algorithm does ChatGPT use? So suppose we are using, so there are various tokenizing algorithms, right? You can use a simple word-based tokenizer. So whatever may be a word-based tokenizer, if you see this whole paragraph here, this data here, which is here, so category can be one token, say the is one token, one is one token, like that, right? So you can have each one of them as a token, right? But again, it's a big science. I won't get into it. So we are using a simple word-based tokenizer, but ChatGPT uses byte pair encoding and other kind of advanced algorithms. Okay, because what will happen is sometimes you get unknown. You can have two words combined together, right? So yeah, so let's not get too much into it. So the concept you need to understand right now is step 3 is basically we are taking the Wikipedia data's processed output, converting it into small tokens. And these tokens are not just words. Even comma can be a token, full stop can be a token, exclamation can be a token, right? Numbers can be tokens, and every one of them is a token with a token ID. Okay. So typically, we create a dictionary, right, of the words. Now, if you want to visualize what these tokens look like, okay, so let's look at OpenAI's tokens. Okay. So OpenAI built this tokenizer. Okay, I'll put this in the chat. Okay, you guys can have a look at it. So this is OpenAI's tokenizer, where you can enter any text you want. Correct. So ChatGPT is amazing. Okay. So you see that it creates tokens like this. It breaks it down to small pieces, and you can see this, and you can actually see the token IDs also what it's generating. Okay. So this is the base using the tokenizing algorithm what ChatGPT has written to calculate the tokens. So this is useful for you to understand how much of cost you're going to incur, right? So suppose you're saying, you know what, I'm just putting a big paragraph, a PDF containing a lot of data. You want to understand how much you'll be charged. You can calculate your tokens over here, right? Now, what tokenizing algorithm is using, we don't know, right? But it is using these many tokens, and these are the token IDs that we can know. Okay. Now, inspired by this, right? Inspired by this, we built our own tokenizing application as well, right? So one of our cohort program members, right, whom I this thing, who's part of my cohort. So we built our own vocabulary of 30,000 words by taking Wikipedia data. Okay. And we built our own tokenizer, right, using a simple word-based tokenizer. Okay. So here, in fact, it's processing because the backend is in render. So there's a cold start involved, right? So here, again, if you type anything, it will also give you the tokens just like you get from there. Okay. So pretty much at a high level, if you look at it, what does the tokenizer do? It takes your words, converts them into tokens, correct? It takes all that, whatever 1.6 GB I showed you, right? It converts, of course, it pre-processes it. It gets a less smaller file, which is the corpus file, which is much smaller. And from the corpus file, it breaks it into tokens using the tokenizing algorithm, which I showed you right now, right? The advanced corpus tokenizer, what I showed you, right? So this is the tokenizing algorithm, the class. It uses this to tokenize each one of those words, right? And then creates a tokenizer, right? So Wikipedia underscore tokenizer, and finally it traces a tokenized output, right? Now, what does the tokenized output consist of? Very simple. It just consists of numbers and mappings like this, nothing more. For example, science is cool is a sentence I got from somewhere. I break it down into small 3 tokens. Science will have a number, easy will have a number, cool will have a number. Okay. So just like you're seeing these numbers here, you can also type it in our this thing here. Science is cool. Okay. So you'll see that we will also be able to generate our own tokens for this. Okay. Can you see this? Science is cool. We have 3 tokens, 339, 11, and 6240. Okay. But these IDs are generated by us using our algorithm, right? Now, if I give some words which is out of this, right? Like science is cool, says whoever, whatever. Okay. So anyway, okay, let's not get too many things. So now we are clear about the tokens, correct? So you're creating a dictionary pretty much, right? A dictionary is something like this. Just, if you see this diagram. So you're looking at the brown fox, jumps, lazy, dog, over, quick, each one of them is token IDs. It puts in and just generates a reverse mapping. Why do we need this? Because we need at the time of decoding it. So the model predicts the next token, and ultimately what it predicts is the token ID, and we convert the token ID to the words, and that's how the ultimate New Delhi comes. Okay, from the dictionary it comes. Next thing what we do is create sequences. Now this is where it gets a little bit more involved, right? The core training architecture comes here, right? So this is something that's unconventional in how it learns and trains. Okay, so the input is basically the tokenized corpus. We created a tokenized dictionary, right? And output is training sequences. Okay, so what are these training sequences, and how do they get into the training of the model? So typically what we do is when we train the model, right, we basically create various training sequences, which are input target pairs required for training the LLM. Okay. So LLMs are pre-trained by predicting the next word in a text. So if you see this diagram, right, it becomes clear. Suppose I have a sentence, LLMs learn to predict one word at a time. Okay. So here what happens is it's more like when you are learning, when as kids, when we learn, right, we suppose English words and meanings. You cover the meanings and then you try to guess the meaning of the word, right? So when you open it and see, did you get it right? Did you remember it right? Right? Pretty much that's how we learn, right? So here, if you look at it, here also we are trying to do the same thing. We cover the pink ones, okay, and the model tries to predict each time, okay. So it says, okay, if you see here, LLM learns to predict one, and then there's a pink word, correct? So it tries to predict word and sees did it get it right or wrong. If it gets it right, great. If it got it wrong, it will understand what went wrong and adjust its weights. Okay. Now, what are weights now? What are they coming? Where are they? I'll come to that shortly. Okay. But the important aspect is these sequences are what is an input in terms of how the model learns. Okay. Typically, if you see it, right, they say, okay, it's trained on a lot of data. Okay, petabytes of data. But typical classic machine learning? How did it happen? If you had dogs and cats, right, you gave 100 dogs and 100 cats, and it understood what is a dog, what is a cat. And if you give a new dog, it will tell you if it's a dog or a cat, a new image, right? But here, if you're looking at petabytes of data, who is going to do the classification? Who is going to do that labeling, right? You can't really do it, correct? You can't really go and say, this sentence is this sentence is, it becomes too much, right, for anyone to do it. So LLMs were built on this genius idea called let it train by itself. Let it look at the sentences by itself. I will provide the sequences. That's it, right? You let the model itself keep learning and iteratively, continuously update its knowledge based on what it's learning, based on this training sequences. That's it. So this is a central tenet of how it learns by itself. And the outcome of this approach of training is what has also helped. And even the people who develop these models are surprised that in this way, it has also learned about translation, language translation, and other things also. It has built that ability to do that and perform a lot of other tasks as well, like sentiment analysis, classification. It has built it because it is automatically updating its weights, and it has a lot of context by just doing this training in this manner. So how do we actually give this training sequence, right? So let's say I have in the heart of the city stored the old library, right? So you create multiple tensors which look like this. What is the input and what is the target? Input, target, and it keeps on getting it. Now, this looks a bit confusing, right? You think it's all English. It is not English, right? It's all tokens, correct? If you see this is how the training sequences look, right? So you're giving one input sequence of 45, 892, 123, right? These corresponding to the words, correct? So as I said, all the words, what you're seeing here, in the heart of the city stood the old library, they are converted into tokens using our tokenizer, what we already discussed, correct? So using the encoding, it converts from the English word to the token ID and represents in a sequence like this, correct? So how many sequences do we want to have, right? So one input sequence is 512 tokens, and then you prepare the target sequence. So how is this interpreted by the model, right? When you prepare the sequences and give it, right, the fourth stage is giving the training sequences. It is making 512 predictions. If you can see this, it's making 512 predictions and improving itself, right? So how does it look at it? So 45 predicts 892. 45 and 892, these two are combined to this next index. If you see the index, right, under 892 is 123. So 45, 892, 123, 67, correct? So that's how it predicts the next token every time, okay? So so the last position 511 will predict based on all the tokens before that to predict the next token. So this is how it continuously keeps on learning and getting better and better, okay? So if you want to understand again, what is the training now? Okay, you said, it's taking 40, let's take this third one, 45, 892, 123, 67 and predicted 234, okay? So suppose it predicted right, or it learned something out of it. What is it learning? What is really improving, correct? What really improves is the weights that it adjusts for every word that it has, correct? So like I said, we have a vocabulary of 30,000, okay? So if you see here, this is a model developed by our guys, right? So if you see a vocabulary, this is 30,000 vocabulary got from Wikipedia data. So we took Wikipedia data. This is a separate activity, okay? Not part of this. Separate activity, we took Wikipedia data and we got 77 lakh sentences, okay? And out of the 77 lakh sentences, when we tokenized it, right, using our own custom tokenizer, which is a simple word tokenizer, no jazz, okay, we got around 6 lakhs tokens, right, unique tokens. Now, out of the 6 lakh tokens, we said, some of these tokens will be like hi, right, bye. So we were like, I really am not interested in, those kind of stuff. So they should have more frequency, right? Like some of the tokens can be just like Ashish, right? Because you're getting any random data from Wikipedia, you can get some Ashish or Michael or something like that. And we said, I'm really not interested in those because I don't have so much computing power. So let's just take most frequency greater than 2, and I collected 30,000 words, right? So these 30,000 words, now if you want, you can actually search for this hello, right? So typically, can I find hello? Yes, is there in our dictionary, because hello comes more frequently, correct? But if I say something like Ashish, right? Will I get Ashish? No, right? Because we said the frequency is not more than 2. So no use in just filling into mine, right? If I'm never going to use it. Of course, ChatGPT will probably have it, and they have their own way of doing it. Now, why are we talking about this vocabulary? This vocabulary, what we have, ultimately is going to have embeddings, okay? So these are the embeddings that are going to get created using Torch, okay? So using Torch, we create a random set of embeddings, okay, for every word. So you see that there are 0 to 30,000, right? Now think, you create embeddings like this, which has a particular dimension, right? Dimension is 512 here. Dimension is total number of columns that we have, right? And why do we have 512 dimensions? So I want to represent each word in so many dimensions, and continuously as a model is training these weights, what are saying each one of these values, numbers keep getting updated, right, for that particular word. So you have something called token embeddings, and you also have something called positional embeddings, okay? So why do we need positional embeddings? So token embeddings makes sense, right? So you have 30,000 words. So therefore, each word has embeddings which have been generated by PyTorch, right? Now, initially, these embeddings what are generated by PyTorch, these numbers are all random, absolutely random, okay? So they make more sense, but you just put in some number out there so that you are going to improve those numbers to make more sense. It's like a small kid trying to grow and learn and connect the dots, right? Initially, nobody knows language, but gradually they understand the language because you keep saying sentences and they keep thinking, okay, if you said, oh, you are a good boy, the kids start understanding, okay, you are a good boy means it's a good feeling, right? It's a good, something positive, something good about it. So that's how even this continuously keeps on evolving, correct? So you have token embeddings, and for 30,000 words, it makes sense, right? But why do we need positional embeddings? So what are positional embeddings? You have 512 positional embeddings, and the same number, the dimension will be same as the token embeddings dimension, right? Same 512, right? And why are these positional embeddings needed? Basically, we are saying that it is important for, again, you see the central tenet of transformer architecture is attention, right? So it's very particular about what order a particular word comes in, okay? So let's say I have a common example that is generally given is man bites dog, dog bites man, okay? And man bites dog, right? So if you see, both of these mean different, right, in English parlance, right? So if you don't take the positional representation, if you see dog as an embedding, it will have its own embedding. Man will have its own embedding. Bites will have its own embedding. But if you don't take into account the order in which these embeddings are happening, right, these words are occurring, then the model will give you something wrong output, right? Good on this. So that's why we introduce something called positional embedding, right? So we say positional embedding is important to understand where a particular word is coming up. Okay, got it? So that's why we take positional embeddings, and that's why we are taking 512, right? So can someone tell me what is this 512? Is it the same as the context length? This 512 positional embeddings which I'm taking over here, can someone tell me, could this be, like I'm saying only 512, right? Would this 512 be the context length of the sentences which I can accept? Anyone has an idea? So now I'm saying token embeddings plus position embeddings together are what is sent to the model. Okay, that is how it is. It happens. So if you see my screen, ultimately you have a shape of 30,000 512. That's the token embeddings time matrix. Position embeddings is 512 by 512. Okay, so typically that's the context length that I'm accepting at any point in time, because I can have a sentence with only 512 words in it, right? Or 512 tokens in it. For each position, I have an embedding, and I'm going to overlay the token embeddings for that token plus the positional embeddings for that, and then pass that into the transformer architecture so that it can determine the next token prediction. Cool. So this is what happens if I don't train a model, guys. So first time when I generate these weights, this positional, these token embeddings the first time, okay, and I give it to a model, this is how it looks, right? Untrained model will say, if I give computer word, it does not get any similarities between the other embeddings, correct? So how the embeddings work is similarity, right? How each embedding is close to each other. You'll see that the untrained one gives you some random stuff, while trained one will give you computer software, right? This is after it is trained on what we are trying to train on right now. Okay, so that is how the weights get updated, and that is the exercise we want to do now. Okay, so the next step, any questions so far? All good? Yeah. So now if you see out of the original thing that we wanted to do, what all did we cover? So download Wikipedia data, we did it. Pre-process the Wikipedia data into sane data, clean data. Tokenized it, just like what we saw over here. We kind of used our own tokenizing algorithm. We tokenized it and created a number for every word. They created a sequences. So we said, let me create all the sequences just like what I showed in that slide over here. Out of all the sentences that I got from that, corpus, I will create this, sentences which look like this, right? In a format which looks like this, okay? And then pass it on to the model. Now let it train. The next step is training, okay? So now you got to a point where you are getting sequences. You also understood what is the embeddings that are getting updated in terms of their weights. And next, start training now, okay? Let's start training. So to train it, what do? We have a GPT-model.py, which is the okay. So let's open this file. So this is the core model file, which has the multi-head attention, the transformer architecture built in. Okay, so you define your weights, your forwards, and everything that's that goes into this. Now you have your QKVs and all the other stuff. So we won't get into this because it's the feed forward layers and everything, the transformer block. You can see everything in this. This is the core file. Okay, the core model file which we are going to use for the purpose of training on those sequences what we generated. Okay, so this is the brain, and this is where all the attention layers are, the feed forward layers and all are there, right? So again, it's an explicit implementation of a transformer block. Okay, it manually defines attention, multi-headed self-attention, feed forward network, layer norm, and residual connections, and all those. Okay, so so again, we'll move on. So the next thing is train the GPT. So we defined that model, and now we are going to train it. Okay, so this is the file where we are going to train underscore, what's the name of that file? Train underscore. Okay. Yeah. So if you see, this is a file which is actually taking that model file what we took it taken. It takes all the sequence data, training sequences. You can see it here. It takes all the training sequences and trains a model continuously. It trains it and it opens up all the parameters, updates the weights, and builds a model and gives the final output model, which is GPT-2 underscore final dot PTH. Okay, can someone tell me what is the significance of PTH? Why is the extension PTH? Anyone? What is the difference between .pt and .pth? Does someone know? No. So basically, PyTorch creates as .pth, right? So if at all using PyTorch, it creates the output as .pth files, right? So that you can consume. So that's why you cannot use Nano or something on that. So you'll have to try and use Python itself to open it. And I was trying to do that only, and I tried installing Torch over here. It installed Torch and it messed up that NVIDIA this thing, the CUDA thing. So it's okay. So coming back now, where are we? We said train GPT-2. Okay, so it went ahead and took all the training sequences, and it said the model is ready, right? Now where is the model? .pth file. You can see GPT-2.best_best.pth. I think this is a file which got created. So let's try to run inference. Okay, now that the model is generated, now we have a model which is done on the training sequences. So again, just to recap, where are we? Okay, so first we downloaded the Wikipedia data, pre-processed it, tokenized it into words to numbers, created the sequences. I showed you the sequences. Then we trained it using that model, that transformer architecture model. using those sequences, we trained it. It built a nice model which has some good understanding now, and stored it into .pth. Now let's do the inference, right? The final stage, the model is ready. It's exam time. Let's see what happens. Okay. So right now, I think I need to be the VNV. So let's source VNV. I hope it runs. Okay, so great. Now Python 6_ test generation. Okay, so let's just generate the output. It's going to kind of getting the next token prediction, right? So we built a model which is going to do next token prediction just like ChatGPT. Okay, right? Now that was the intent. We did a lot of effort. In fact, we ran this whole thing for nearly 20 hours, 20 hours on this powerful GPU. Okay, and it gave an output like this. Okay, so if you can see the output, it looks gibberish, right? Absolutely. So absolutely no relevance, right? No information, no meaning, and you see cosmetics is repeated so many times. So it's all over the place, right? So literally we spent 20 hours and all of it has gone to waste if you look at it, right? So typically this is what happens when even large companies train their models, right? They run them on thousands of GPUs, several months, right? And if you don't get it right, the time's gone, it's waste. Of course, you have the learning, right? You have the learning, but there is no tangible outcome that comes from that. Apart from, of course, the other artifacts that you create, the tokenizers, they're all there. That is all there. But the core model, the time of the GPU is gone, right? It's gone. So now we were like, oh my God, it's really very disheartening, to see something like this. And then we figured out, we did some research and figured out the root cause. Okay, can someone tell me what would be the root cause? Just a guess. Why is it, we spend nearly 20 hours on the GPU, right? I know it's not enormous amount of data. We just took 1.6 GB of data, right? I mean, ChatGPT will take petabytes of data. Okay, we are taking only 1.6 GB, but still, the expectation was little bit somewhere, right? At least a few words here and there, but can someone tell me what could be the reason for this? And
Maybe because while we are generating tokens, we are just considering how to say library of words, right? So
yeah,
what might happen in that case is it is just giving a number like ABCD 1 2 3 4, and whenever something is like India and maybe capital you say, so there is some kind of relation between the words. That relation is not actually uh, captured by tokenizing in that way. That might be one of the causes.
yeah. So yeah, that's good. So multiple problems. Okay, so one is, the first thing is, we don't have a huge amount of data on which we train. First of all, okay, it's just 1.6 GB, right? And if you look at it, Wikipedia data that I showed you, right? I just showed you somewhere above. If you see this amount of data, it's all over the place, correct? So there is some a little bit of religion. There is a little bit of birds. I don't know. This is alphabetical order of birds. It's all over the place. Okay? So imagine if I told you that you are appearing for an exam, and I told you that your syllabus consists of history, geography, space, and a whole bunch of 10 different subjects, and I'm giving you one exam paper on this. How much will you be able to focus, right? You're not going to be able to focus, right? So you'll not do justice to any one of them, correct? So I think that's exactly what happened here. If you look at it, the amount of data we had was huge. It wasn't really able to train on anything properly, correct? So the learning from this experiment is, if you really have to train it, you have to either have a huge amount of data wherein it gets a good understanding of the whole context of everything, right? And that's why ChatGPT does that petabytes of data, but we don't have the computing power, correct? So what we did as a natural progression next to solve this, okay, we said, okay, this is disheartening. I mean, it's wasted of time. So next step, we said, let's do one thing. Let's take a smaller data set. Okay. And what is a smaller data set? We said, let's take only one domain, which is football. Okay. So let's take only football data and try to see what we can do on that. Okay. So then we said, okay, let's go for Mini GPT 2, which we said is only football data based. Okay. So we said, take only football data from Kaggle and use that football data to train a model. Same process, everything same. Again, I won't go into the steps, you know the steps, exactly the same thing. But we did a slightly different thing this time. We didn't want to really, take the football data. Again, football data can be huge and vast, right? So what we did is we took uh, the numerical data of football matches, right? Who won, who lost, what teams were there, and then converted them into sentences, okay? So that all the sentences looked similar, okay? So if you see here, what we did was, yeah. So yeah, we took a football data, okay, and yeah, I'll show you the file. So I'll show you the output first, okay? I'll just deactivate this first, and so I'll just activate this particular folder. Yeah. So I'll just run it first so that you get an idea of what to expect. Okay. So Python generate football. Okay. So when we ran this, if you see the next token generation for this, if you see, it looks a lot more better. Okay. At least it looks like, okay, I said the prompt is Manchester United 1. And if you see that it says Manchester United 1-1 against Reading in English Premier League. The home team dominated the match. Manchester United defeated Reading 2-1. It was a convincing victory at, okay. Of course, it is truncating to where it is, correct? So if you look at it, this looks lot better, correct? At least it looks like, okay, something, it's continuing the sentence. If you look at it, the match ended and then says 2-0, and then it says something else, right? Now, see, again, you see there will be some irrelevant stuff in, you see the sentence construction is not perfect, right? You see it's random, right? It's not perfect, but it's okay, right? The point is, we gave it, when you gave it a focused kind of a data set, right? It was able to give a much better outcome. Okay. And that was the learning, that we, if you are training it, and again, you need to make this better. Now, if I want this to be better, I need to train it on a lot more data than what we did. Okay. So this particular training, because the GPU, it got over pretty fast. But the important part is, the key learning, again, what we have and what I will do, probably what we will do as a team, as a part of our cohort work, is we'll probably train it on just a few amount of data that we need for our domain, right? So today, if you see, there is something called verticalized, verticalized LLMs, right? So typically, the LLM you use for ChatGPT, it can do everything, right? It can do everything of everything. You ask it anything, it has knowledge, it can do it because it's trained on petabytes of data. But how about we build something that focuses only on what we need, rather than a whole generic model by ChatGPT, and we pay a lot more, right? So if I want a specialized service, I pay for the specialized service instead of paying for service which is giving me, which I don't need, correct? So the goal is, why not again train it on a lot more? So we work in agriculture, right? And why not, for what some of the use cases, build this and train it only on the core agriculture data we need, where our end users can be using our model, right? I don't want to go to ChatGPT for this. I want to use our own model, which is a verticalized LLM, which will serve our needs, correct? And I think this kind of an experiment, or this kind of a work, gave us that little bit of confidence that we can do it. It makes a lot more sense. We train it and we build it only focused data sets related to agriculture, and specifically Indian agriculture, and then train it on that and build our own model. Okay. And those are the next steps, what we're going to do in terms of how we want to proceed, correct? So again, for this, just a little bit of technical depth, how we build this, we kind of took the match data and then converted them into sentences, and then, tokenize them, and, again, train the model. Same process, everything same process, but you see that the output is a lot better, and it's pretty interesting that we can do something. And this does not use any existing model or any pre-packaged .model file or PT files from anywhere. It's entirely from scratch up. Okay. So that's the thing, guys, at a very high level, in terms of what I wanted to share. Okay, it's pretty much 12 o'clock. I think we're dot on time. We can take some questions if you have any. I don't want to bore you for more than that. Yeah. So anybody, any questions? Any quick thoughts? Yeah. So just wanted to again just let you know, we do some of, again, I cannot cover everything of everything. So I run a program which I think I have shared in the chat. So if anybody is interested, you can join my program. You can just have a discovery call with me. You can see if it works for you, right? I run this training program for AI engineers, right? And so we actually cover a lot of this theory and underpinnings and how we build, step by step, right? Some of these files we build step by step. It's a proper training program for helping you get the hands on my GPU. Also, I give you a GPU access, and we build it. And I'm actually looking, some of these models have been developed by a 2026 grad, right? The third year student, right? He has built some of this stuff, and he's pulled the data. And in fact, he only ran everything. I'm just giving the presentation, guys. Okay, so that's how it is. But the goal is not to just run something; it's to understand the inner depth so that we build our own stuff, right? We should build our own stuff, and I'm sure we will build something out of this. At least for agriculture, I am confident we can build. I want to build that verticalized LLM which will cater to Indian agriculture for sure. That's my plan for sure. Okay. Any quick thoughts, anyone? Any questions? I think we are done for the day. I don't want to take out too much of your day on Saturday. Any questions? Any thoughts? I mean, I hope you people were able to follow, right? I hope it wasn't overwhelming, right? I try to make it simple. That's why I didn't get into the hardcore multi-tensions and all that. But probably we'll do that in subsequent sessions when we see if we are making any learnings out of this, right? Where we break it down into a smaller piece, right? In terms of again, the goal should not be just copy something, right? What OpenAI is doing, right? The goal should be how do we tweak it based on what we need. Like the learning we had right now, Wikipedia is too broad-based. We pick up a smaller domain. Now in the smaller domain, can we tweak the existing architecture, right? If you see again OpenAI, right? They did not blindly copy what attention is all you need came up with from Google. They built their own thing. They just said we don't want the encoder decoder architecture. Let's just do decoder only, and they're done with it. Correct? They're pretty successful, and that's where innovation is, and that's where innovation should start. Here also in India also we should do that innovation, but it comes only when you tinker around it, play around with it, make mistakes, and that's how we've done it, right? That's how the thing happens. And trust me, it's cutting edge in terms of again, a lot of people think oh, we don't have access to petabytes of data, so we can't do it. No, you don't need to build it, right? You can build verticalized LLMs which solve only a specific problem, and that is the future according to me, right? Building large foundation models, I don't think will work out in India. Honestly, it's too compute expensive. Data is enormously required. But verticalized LLM, building a small specific domain LLMs can also help you build a startup around it, right? Which can solve a specific problem for someone, right? So we are anyhow building for agriculture. I'm building it for agriculture anyways, and I'll have subsequent sessions where I'll talk about how we're making progress in terms of how we're building it. Okay, yeah. So again, the goal is again to provide it as a larger model available for research for anyone, and also for our AgriGPT application, right? So the goal should be that we reduce our dependence on the other models out there, because we don't need to pay ChatGPT for something which we can do at a low cost. But again, don't make the mistake that because we build our model, it's free. Correct? It's not free, because you have to host it on a server and run it continuously, right? So unless if you don't have a huge inference, right, a huge amount of API calls being made to you from your end users, you just have 10 users and you're spending like 30,000 per month, you would rather go for ChatGPT, which you can use for, like, say, maybe 100 rupees, right, as compared to that. So it's a trade-off involved, and I think some of these benefits come when you scale, right, when you work at scale. Correct? But again, that's the learning by itself, right? How much of cost is it going to take? At what point do we break even in terms of using our own model and deploying it vis-a-vis using ChatGPT? But the biggest control we get is what kind of a quality of output we give, right? We get that control over ourselves, and that's I think is the beauty of the whole thing. Because today ChatGPT is a black box. You hit it something, you will always get what it wants to send, and stuff like that. Okay, so. Yeah, that's it, folks. That's it. Thanks for your time. Any questions? I can take another 5 minutes. Otherwise, we're done. Thanks for attending. I know on a Saturday morning, around 35 people showed up. That's great. Thank you, everyone. Right, and whoever is getting these fireflies, yeah, I hope you folks also check it out later. Okay, thanks, everyone. Thanks for your time.
Vijender, sorry to interrupt.
Yeah.
So
Yeah,
my requirement is with dynamic data, which is in web. So let's say requirement is with sales, okay? So lead to opportunity conversion, there needs to be a data my model should work on giving me suggestions about that company, how should I deal with that company or stuff. So is that implementable with this mini models?
See
Because
here, see again, if you look at it, we are not predicting anything over here, Shekhar. We are just predicting the next token kind of algorithms what we built, correct? Pretty much it says if I give you, if I ask you something, it learns and trains and predicts the next word. Pretty much that's what it does. I think what you are looking for is something slightly different, right? So what we can do, you're around, right? Just drop by. We'll just connect and get it going. Okay.
yeah, actually,
I'll
I'm
suggest-
planning come this week and join the program. Actually, now I'm free and I want to join the program.
Yeah, sure, Shrikant. Come over. We'll connect and we'll start working on that. Yeah.
Yes. Thanks, Vijay.
Yeah, sure. So SLM again, Goodtrade is asking SLM same as Mini GPT. So what we have built is is a very basic version of it's not really like a big anywhere close. SLMs basically again there are various school of thought. Basically they say if you have a lesser number of parameters, right? So typically 3 to 7 billion is 3 to 10 billion I think is what classifies as an SLM. We are nowhere. We are just like I think 110 million parameters. That's it. Not even 500 million. Okay, so yeah, what we have built is not anywhere close. No. See, the idea is not to worry about building an SLM or anything. The idea is to get the raw power of understanding what goes under the hood, right? And making those small tweaks and making those small changes to solve your problem, right? So whatever problem you have to figure out how do I solve it using this architecture. And now, not everything. So there was also something called intent classification we wanted to do with this, but then we thought intent classification using this GPT architecture is an overkill, right? You really don't need a very powerful architecture like this for that. You can use classic ML for that. So again, which model you use and should be based on the problem you're solving, correct? Otherwise, it's a waste of intellectual resources and time, right? So yeah, intellectual capability, resource, and time. So model should only be doing what you expect it to be. Like for here, we are saying next sentence, next token prediction. Why is that important? Because I wanted to understand language. I wanted to communicate with me, right? So that's important for me. Why do I need it? Because today I'm depending on ChatGPT for all of our inference. Now I'm saying we build our own stuff which can do. And why do I feel we can build one? Is because our vocabulary is very limited. If you look at it, right? If I'm focused on agriculture, I'm only looking at a very small focused set of corpus of data. Right? It's not enormous. It's not. So with that 1.6 GB, I can get a huge amount of data I need just for solving a few problems for a few farmers, and we'll scale it from there and keep adding more corpus as we go, right? That's what it's about. So that's the thing, guys. So thanks everyone. Thanks for your time. And yeah, Harish. Yeah, go ahead, Harish.
So Vijay, can you please let us know the course you're offering and what for the intended audience and what can we expect and what's the fees, etc.
Yeah, so all the details are there on the program page. Okay, it's on my page, and again you can explore programs over here. Okay, so typically I'll tell you at a very high level. Okay, the link is here. I'll tell you about a very high level. What is the concept behind it? So I believe that you need to work on projects, right, to be effective at applying your knowledge, right? Most of the times people read YouTube videos and just get stuck there. But if you actually apply it and actually run these files and you see the output, it gives you don't forget, right? So there are 6 projects. This program is for 12 weeks. So each project you have to complete in 2 weeks. Okay. Now daily from 7 to 8 I have a live session, right, where I talk about each project. So if you see again, again the people who are want to drop off can drop, guys. Okay, this is more about my program. I'll just talk about it. So if you see mini LLM from scratch, right? So there will be 12 points. So all these are topics which I cover in each project, right? So project 1, I'll cover all of this: understanding tokenization, word embeddings, transformer architecture, multi-head attention, feed forward. So in 2 weeks, you have to complete all of these topics. I will teach every day. I will give you small videos for understanding the theory. in addition to the live recording. Suppose you're not available in live recording, I'll give you small tasks. So we have something called project school, which we built, okay, which is the revolution, what I have brought in for the tech space, right? If you see, this is how project school works. You have all these tasks, correct? So you keep completing these tasks, and in 2 weeks you have to finish that project, come what may, no excuses, okay? So typically what people do is they enroll for a program and they stop in the middle. So here you don't stop in the middle, right? You finish that 2 weeks and you're done. You built an LM from scratch, you're done with that project. Now we move to the next project in the next 2 weeks, okay? So here is fine-tune and last time translation model. So I cover what is required for fine-tuning, PEF, LoRa, QLoRa, quantization, and all the stuff. So in 2 weeks, you will be done with this project also, and you will be like literally, on top of the game with this project. Next, we move to e-commerce product search and recommendation. So multi-model RAG agents and whatever is required here, right? We cover all of that. And then customer support AI. This is a different project. So different projects cover different concepts, right? Like this one covers agents. Focus primarily on agents. So different project is focused on this so that you get an understanding of that, right? And then document intelligence focus on NER, PDF processing, OCR, and all that stuff, correct? Fraud detection for real-time ingestion, time series, I think some of what Srikanth is asking. So LSTM networks and all this, right? So Bookyard is an open source project which we are doing, and I'll make you do this also, right? So the goal of, again, we also cover DSA, guys, okay? So because data scientists today require DSA, I'm also giving some DSA questions for people to practice, right? I want you folks to be on top of the game. So again, we have something called basics also, React from basics, Python and DSA. So people who are interested, and not everybody gets it, people who are developers, want to be AI engineers, they need to be strong in Python basics, right? You need to be crushing it with respect to setting up fast API endpoints, Swagger documentation, and so on and so forth, okay? So this is a concept. The main thing about our thing is Study Buddy, right? So Study Buddy is our agentic AI application which we developed in-house by me, okay, and the team, of course. So we this agent is what monitors you and make sure that you complete it. Okay, in 2 weeks, if you are not completing it, the agent will send me a report, send you a report, and you can converse also if you're busy, you're not well. It's like an interaction agentic AI application, right? That's the innovation behind it, and I get to know because we have a lot of participants who does what, which is difficult to track, right? So Study Buddy is the companion, right? It's your study companion. Okay, so that's the goal. So at the end of these 12 weeks, I'll give a certificate for those who complete all of these, correct? So how do I know you're completing it? So it's through tasks. Everything is through tasks. You need to complete all these tasks and mark as complete. You can see this is completed task. So each task you complete, you mark it as complete, and that's it. It gets into the completed bucket, right? And Study Buddy continuously checks, are you completing or not? Are you doing the current project? What are the other stuff that you're doing? Are you doing DSA or not? Everything is monitored continuously, right? It's that 360-degree roundup of your learning process. Cool. So that's the innovation. I mean, it's primarily about making sure that if you enroll, then you are going to finish it, and I'll make sure you finish it. And I'll call you if required, right? That's how it works. So the goal for me is, you should get the value out of it, right? So you should, and the discipline is important. What people do is they enroll for fancy courses and they never complete. Even I do that, right? Someone has to push. So the pushing factor is Study Buddy. That's what we built. That's what I believe was the gap. And I have not rolled out this program till now. In fact, just today we are rolling it out because we were trying to get this right, correct? The whole concept of Study Buddy, right? And so we made some mistakes, right? Like we added too many tasks for people, and then people weren't completing it. And it again came back to the original thing that you have a fancy tech, but not useful. So then we changed the concept and said, we have a better way of how it does now. Okay. And everything is tracked, guys. Even your DSA is on our platform. So if you click on this, this is our own platform. You submit the DSA also on our own platform, and Study Buddy gets to know, are you even attempting DSA? What's the quality of code you're writing? Everything, right? And it tells me how you're performing. And if people are good, I recommend to jobs. Okay. So recently we had one of our core members placed in a couple of startups, right? He's from defense, right? He's from defense background. He came to me and he said, people are not shortlisting and all sorts of stuff. So then I put him on these projects, and he did amazing work on LoRa, QLoRa, and quantization and all. And he got selected because of that, right? All his work so the second project that was there, he kind of crushed it literally, right? Literally went through inside out and built the entire inference, everything. And he's got a couple of offers now. Yeah. So we do have, and again, for me, the important thing is that the Josh should be there, right? And then I can push it through. Correct. So that's the thing, guys. Okay. So it's a 12-week program, not 8-week. Yeah. So that's any other questions? So happy to answer any other questions. I know I took a lot of time on this, but yeah, people, if you have any questions about my program or what we do, so it's nominal. It's about 5K right now, right? So it's not enormous, but I have a separate training and placement program where I, again, in person, I help all the way to placement. So where you mock interviews and all, that's for 10K. That's a separate program, right? So again, just book a discovery call with me if you want, and we can have a quick chat if it makes sense for you, right? If you're still not sure, does it work, not work, I'm working, whatever other stuff, just book a discovery call, and we can see what works best for you. Okay. For me, the funda is, some of these people who are looking for jobs, right? I put them on some of these projects where we work on them right now. Agri GPT model, we are on the way. We will build it 100%. We'll build in 2 weeks. That's it. That's the target I already said. And people who are in my program, they will only build it. Okay. So it's hand on the job learning for them. And when they sit in interviews, it shows, guys, the confidence shows. Okay. So the candidate whom I referred, he got selected purely because he worked on all the fine tuning part. And industry today does not have people who do that, right? They don't have, because most of them read theory books and come, right? So if you say, people understand the theory of LoRa. LoRa basically says you have adapter matrices on top of the base model, right? But if you see how it loads the model, it has two models, separate models. It generates as output, the base model and the new 17 MB model file. So people don't know that, right? If you do it, you know it, right? Then when you load it, you load both the files and then run inference, correct? And what is the kind of output you're going to get? Is it better than the original one? So I think my last week session I showed, right? The LoRa model is not good. The output is not great. So you put a fancy tech on top of it, but it's not great. The base model, which is fine-tuned, and you quantize it, that model is much better than a LoRa-based model, right? So those are the learnings. Now, what do you do next? How do I improve it, right? Now, you still need LoRa, but how do you improve it? So you have to do it. You have to get into the grind and do it. And I give you the platform to do it. That's what it's all about, right? And I have a GPU machine, NVIDIA 810G, and I give it to anybody in the program. And the goal is, I don't care whether you're a 26 grad, because I've also helped the 26 grad get placed recently. Okay, so he's working in Bangalore now. He's still not graduated, by the way, but you work on a project, I can know you much better. That's the funda. The ultimate funda is I work closely with you. I can know. Study buddy gives recommendations on who are the ones who are performing well, and that's it. Okay. So, any other questions? Happy to take.
Okay. On an average, how much efforts would be required to complete these projects within 2 weeks? It's like 3-4 hours a day, or
Correct. Got a good question. So the way it works is it depends on two things. One is, are you in here this only for just learning, right? At the space that we run at. So I said 2 weeks, one project, right? So typically, if you invest 1 hour daily, it's good enough, right? 1.5 hours daily is good enough. But if you cannot do, right, daily you are having work, I know, you come back and you're tired, you need to finish it on the weekend, Saturday, Sunday, right? All those will pile up and you need to finish them up. But next week you start, you have to again get going, right? So 1 hour every day is 1.5 hours is good enough. So even I give micro tasks, right? So every day, so let's say you're looking at this first project, like I said, 2 weeks, non-negotiable. Now it's non-negotiable, right? Don't come back to me saying I'm busy and all. In that entire week, from Monday to Sunday is the time you get to finish it. So you'll get videos on understanding tokenization, one task, word embeddings, another task, transform active, one task. So you'll have theory and practicals, right? Theory is a separate video where you talk about the theory, what is BP, word piece, and sentence piece. Practical is I'll make you write the tokenizing algorithm, right? Pull Wikipedia data, run the tokenizer, and generate output. See, you don't have to type all the code every time. I'll give you the file. If you have the patience interest, you can do, but otherwise just run it. That itself is learning. You pull a file, you run it, you see the output. Wow, you know what's it looking like, right? So when you're sitting in an interview or you're trying to build your own application, you know how does it output look like? What does the dictionary look like, right? That's the goal. So 1.5 hours should be enough. People who, you don't have to attend the live session because the task will come in, right? That's the thing about Study Buddy. All the tasks will come in and you have to finish. So the current project tasks are mandatory. They get into your system whether you like it or not, and you have to finish it, and Study Buddy will let me know if you're not finishing it. Over and above that, there are optional tasks which you can pick up if you are interested from other projects also. That's up to you. right? I'm not forcing it. Like some people want to get to speed on React, some people want to go to Python. So you pick up the task. So the genius of this is you go to Python, from here you add these tasks, right? And once you add it, they're already added. Then you complete them at your own pace. But that's for people who want to do like full-time job and all that, right? But yeah.
And the output from the candidates is reviewed by this model, or it's manually reviewed? Because people can't just come and say that it is completed, right? Task.
Yeah, good question. See, the way I look at it, who is asking this question is, see, there's a level of, if you are actually opening the task and marking as complete, that itself means that you're actually even looking at this stuff, right? This panel, this dashboard, right? A lot of people just wouldn't even open it up, right? They would just go into pause mode or hibernate mode. So those are the guys I get on. Now, if you see, this is for your learning, right? If you are trying to fake it up saying you're done, it's not helping me, it's not helping you. So you still want to do it, go ahead and do it. But I give the certificate, or every weekend I'll put an assessment test, right, for everybody in this program. It's like, what I figured out, what is the analogy that works, right? Typically, we are like that school mindset, right? So typically in careers, if you see, most people succeed when they are students, right? When you get into professional life, they fail because there's nobody to push, right? There's nobody to assess. But here, every weekend I'll put an assessment where we look at, okay, what all have you understood, right? Are you on track? And I can figure it out, right? People who figured it, right?
Okay.
See, if you said you marked all your tokenizer is complete, embeddings is completed, but you're not able to answer basic stuff about how it works, then you can catch the bluff. See, end of the goal of this is to help you get placed, right? People who need get placement. And when I do mock interviews for people who I feel are ready. So StudyBuddy recommends, are you ready? It looks at this guy, let's say Sitaram is ready. It tells me, this guy is ready for any opportunities, right? And we also have jobs, by the way. So in Alumnix, we have jobs where we put some data science jobs. So I'm not I advertise it much. So whatever internships or we get from my own network, I put them in. And if I feel somebody is good, I refer. So that's how people get placed, right? In my program, I directly refer if somebody is really good, right? But you don't need to complete all the 12 weeks to get placed, right? So the guy who got placed, I think just in 1 month he got placed, right? Depends on Josh. The way I look at it, it's all a function of Josh, right? Do you have the Josh? You want to sit on it, put your life into it. That's it. So trust me, one thing I see is today there's a very huge dearth of good quality AI engineers. I'm not kidding. People think there are no jobs, but the fact is there are no good quality people. There are a lot of people, there are a lot of resumes, a lot of ChatGPT generated resumes, but they're not good people. Yeah, and that's a complaint, right, from industry, that people come with a fancy resume, but they don't have it. They don't have a freaking clue of what they're. You build a RAG solution, ask what is the chunk size, they can't answer, right? So you should have that in depth. So that's why what I thought is, again, earlier I used to make it optional, but I said, if in my program, like you have, in this second one, in the third one, you have RAG, right, over here. In the e-commerce, you have RAG, and you have to finish it, right? There's no compromise. You have to finish it, right? But of course, I can understand sometimes people have personal stuff like, the wedding is going on, or you're busy at work, not well. You can always let StudyBuddy know, right? So that's the agentic AI part of it. It kind of understands, okay, let's take it easy, right? So you do get an email every week and all that stuff. So that's what we are building on. And so that's again an agentic AI application, right? If you look at it, if we are teaching something, we have to practice it, right? So that's what it's about. In AgriGPT is based on what we learn, we implement it. That's it, as simple as that. So we actually built a WhatsApp-based bot, guys. Okay, WhatsApp-based bot, which will, farmers just take a screenshot and send it through WhatsApp. They get insights back. Okay, as cool as that. Okay, so we are still refining it because accuracy is still not up to the mark, but we'll roll it out soon. Okay, and the goal is to use our own model. Whatever we build, our own model should power it. That's the goal. Okay, and you can be a part of it, right? The best part is, I give a chance to everyone. Whoever has Josh, you can make mistakes. That's fine. Big deal, right? So yeah, contributing. You'll actually build the production app. You'll print. So when you do production app, you actually understand everything that does the observability and tracing, everything, right? So that's a part of it. Okay. So yeah, that's the thing, guys. Any other questions?
Yeah, I have a question. So what are the prerequisites to work on this project, and like what kind of roles can we target after completing this project?
Correct. See, one thing is there are no prerequisites, guys. I'm telling you, the most of the groundwork done today for this, all that files, extraction, running, training, everything was done by like a third-year student, right? So that guy is, dedicated 3 months of his time only for learning. Okay, so I think there's no prerequisite. If you're an absolute beginner, then you have this React and beginner modules, right? React, Python, and DSA, absolute modules. You can ramp up from there, right? In parallel, right? So in these 2 weeks, I focus only on one project at a time, and I make sure you're getting there. Now, if you feel okay to contribute to this project, obviously you will require a little bit of React, a little bit of Python, a little bit of DevOps, and all that. And I'll make you do all that also, right? So if you're not strong there, then you will have to take care of those foundation modules I just showed you, right? So, but again, that's a function of interest. So some people want to be only backend engineers, right? Only focus on Python, only focus on AI or ML part of it. So that's okay. So you only ramp up there. You don't have to build a front end part of that project. So even in the project we're doing front end, you don't have to contribute. That's fine, right? That's your goal, right? So if you see, in the screenshot the screen which I shared you, right? Study Buddy here has update goals over here. If you see, right, these are the goals which align with your task. That's it. So what is the outcome you're asking? That's a good question. Outcome and what roles you can target is typically Python developers, right? Full stack developers, like basically React plus Python developers who want to work with real project experience, and AI engineers, right? So AI engineering roles where you are looking at people who can build models, who can fine tune models, who can deploy models. That end-to-end thing, guys. It's not again about just learning. So you'll also deploy. Okay, you'll see the challenges that come with it. Okay, so typically most people try to deploy and render, but when you try to deploy a large model and render, it will crash. It will not work. So I'll give you GPU access. You can run on that. You can see experience. And we can run inference on it and stuff like that. And maybe should we use a quantized model versus the regular model? What's the difference in performance? You should be able to see it and make a judgment out of it. So that's an answer your question. So React plus Python backend, of course, fast API included, and model development and training and building some simple classic ML models also will do, right? Not we won't go into everything of XGBoost and all, but so the goal is to build AI engineers who are like hands-on and who will be like ready from day one. So the first task, if you look at it, right, in my program, if, most of my tasks, they will say fork a repo, clone a repo, and raise a pull request of updating the readme.md, right? So that's the first task I give to everybody, right? And you should be conversant with that. That's the first expectation, and then we scale it to the others. Because I'm a startup myself, I hire myself, right? So, and I see when people come with raw experience and say, how, I'm seeing a merge conflict, what should I do? So I'm like, what should I do? Right? So, you should be ready, right? The goal is ready, contribute. That's what it's. I hope it answers your question, Ajay.
Yes, Vijay, thank you so much for answering.
Yeah. So, yeah, any other questions? Yeah, perfect. So again, if you have any questions, feel free to reach out to me. I'm available at support@almus.com. Okay, so you can send out a mail to me, and I'll get back to you, and we can have a quick call. So you can again book a discovery call if you're interested to know if it does make sense to you, not make sense to you. It's okay, right? So the goal is I want to have some more folks who are more passionate and interested in doing some real stuff. In fact, we are going to launch AgriGPT on a big scale soon. That's my dream. And using our own stuff, right? No jazz. Like, I mean, there's no fun in calling an API, guys. I mean, that's my concept, right? Anybody can build an application by calling an API, right? So you build your own stuff, make mistakes, learn from it, and do it. That's the real deal, right? So yeah, that's it from my side. Thanks everyone. I really appreciate all of you joining in today on a Saturday morning. Okay, take care, everyone. Bye-bye.